Hi everyone, my name is Pulkit. I work as a UI engineer at Flipkart, and today I'll be talking about building server-driven UI. If we talk about any application or any web application for that matter, so the client decides the behavior, the user interaction, it takes care of everything, whereas server is present to back that behavior with the data. And now, few minutes back, Sahil also talked about server-driven UI. So the concept of server-driven UI says that, okay. Now you delegate that responsibility to me. I will tell you how you're going to look like, okay, and how the spatial arrangement is going to be. You just read, you just understand the language, okay, the language that the server and the client agree upon. And what the server is going to do is, it's going to say, okay, I am giving you this configuration. You don't need to use your brain. The client just needs to render what the server tells it to. But that's not it, okay, because that is more or less a solved problem. What I will be talking about is an extension of server-driven UI, which also takes care of the fact that we are trying to extend some business use cases here. We are also trying to make the business code or business use case more configurable. We'll see how. But before I talk, we move to how to build SDUI. But let's understand why SDUI. So I work in the advertisement portal of Flipkart. So generally when brands or any sellers, they come to our portal, there are multiple ad formats that are available, okay? And every ad format, there are some things in common. While they have their own uniqueness, there are a lot of overlapping flows. So generally when an advertiser creates an advertisement, he has to go through a series of steps. Okay, so let's say the first step is some campaign scheduling or budgeting on some campaign details, payment step, and then let's say the campaign is done. So the advertiser has to go through these steps, okay? And there are multiple such ad formats which have, like I mentioned, which have their own uniqueness, but at the same time, there are a lot of overlapping flows in the advertisement steps. So let's say tomorrow, let's say I want to create a new advertisement format. Even if I have the components available in our component library, even if they are available, I will have to create the layout again, create the spatial arrangement again, stitch all the steps together. Just like I mentioned, it's a multi-step process. I have to stitch all the steps together again. Okay, so I have to handcraft the UI again. So now what if we can make it about configuring the UI, rather than handcrafting the UI? So this is where the idea of server-driven UI stems from. And also, before we move to an example, why do we actually like to write code in React? So React follows a declarative approach, right? So React says, I actually do not care about what you do inside that function, okay? I'm giving you some hooks. You want to change the state of the component, you can go ahead and do that. You want to perform, let's say, any side effects. That is more of imperative code, although you can use effect. But in the end, what I need is, whatever you do is your headache. In the end, what I need is a DOM element from you, which I'm going to render. It follows a more declarative approach. And one more thing, if you notice about, not particularly for React, any other declarative framework, is that you know beforehand how the UI is going to look like. If this is the condition, this is what I'm going to render. And let's say if that is the condition, I'm going to return this thing. So beforehand, you know what you're going to render and what is going to be there on the screen. So server-driven UI or SDUI also takes inspiration from this idea. So we have actually three problems at hand: presenting the UI, validations, and putting the workflows together. Let's look at them one by one. Presenting the UI. So although it's a very simple example, but I feel it is sufficient enough to put the point across. So I mean, if you look at it, so there is, let's say some React component named Node1, and this is a component that has three children, Node2, Node3, Node4, and then at the bottom there is another component, Node5. So if you look at it, like, it's actually an array tree where, let's say, the body is the root, this is another child, this is another node which in turn has 3 leaf nodes, and this is another node which is acting as a leaf node. So now JSON is actually the simplest data structure to represent this UI. So obviously there has to be a server SDUI framework that understands this language. So if I have to write, if I don't want to handcraft this UI, okay, if I want to present it in a form of a configuration, there has to be some framework behind it, the server-driven UI framework behind it, which understands this config and can render the UI. Okay. So now, if I have to present it in a form of config, and one more thing, there has to be an asset factory behind it. What it means is, let's say you say in your UI config, okay, the name of the first component is Node1. We'll come to the middle one later. The name of the last component is Node5. There has to be an asset factory behind the scenes which understands the mapping. What do I mean by mapping here? So name Node1 means a component which is mapped to any React component or any other framework that you're using or any other library that you're using, map to a component in that library. So your framework understands, okay, if you give me a key called name or give me a key called node, then I'm going to map it to that. But let's say you have a special case where you say, okay, no, I don't want the stacked arrangement. I want a more logical container where the placement of these elements is a site. What this means is they are adjacent to each other. So you tell it, okay, the placement, and this is a language that the framework understands. You say, it's a logical entity, the placement is site, and these are the children. And again, the same thing. These nodes are mapped to a particular component in the asset factory. So, you see how we were able to represent the UI in the form. I mean, you can obviously add a lot more things to this styling and all of that, but this is a very trivial example. But this is actually a solved problem. When I talk about SDUI or what we did with SDUI, this is actually a solved problem. We did not do, I would say, a lot of new things here. But what we tried to incorporate was adding or making the business logic also configurable. And we will see why it is important, because this, more or less, if you see, right, configuration-based UI is actually a solved problem. A lot of people over the years have done this. Okay, so let's move to validating the UI, and here we'll understand how we are making the business logic also configurable. Okay, validating the, before we move to validating, I will show you a quick video. Okay, and this page that you see is also, it's one of the steps in the onboarding flows of the advertisement, in the advertisement portal of Flipkart, and this is also built on built using SDUI framework that we use. So you see, right, as soon as you click, I want you to notice two things here. As soon as you click on the date selector, it says campaign and cannot be empty, or the error message. Second thing I would want you to notice is, so it will enter some budget here, and I'll ignore the business use case here. So it clicks on the second radio button, and notice that this drop down that is present here will just vanish. I'll not go into the business details as to why this is happening, but just we'll assume that this happens. Okay, so as soon as second radio button is selected, what happens is the drop down just vanishes. Okay, so now if I have to add these, and why are validations required first of all? Like I mentioned, it's a multi-step process to create an advertisement. The user can go back and forth. The user can come back at any time from step 1 to, let's say, step 2 to, let's say, step 1. But the important thing is the user cannot just go forward whenever he wants. There has to be some sort of guardrails presence or some sort of error handling that has to be there, so that the user can, first fix those errors and then go ahead. So this is where the concept of rule comes in. So, instead of handcrafting these conditions again and again, and this is where the concept of reusing the business logic comes again, because no matter where we are using this particular piece of code, this UI, we are using it on web, or let's say tomorrow we write this code for a mobile app or any PWA, the business logic is still going to remain the same. The fundamental of advertisement creation is still going to remain the same. The rules are still going to remain the same. So, instead of handcrafting that again and again, can I have a logical separation of the imperative part of coding where we have to light all the if-else conditions, and can we have a more declarative approach of writing these rules? Because you don't want to write these rules again and again, right? Because, rules are not going to change. Your UI might change dependent upon the device or whatever your application is, but the rules are still the same. So this is where the concept of rules come in. I will call this as a static rule. We'll see why that is the case later. So this says the example that we just saw, and this is again a tool called, in our SDUI framework, it's a tool called Rule Engine, which is able to understand this language. Okay, a rule engine understands two things. The conditions that you provide are either a logical and or a logical or of the conditions that you've defined here. So what it says here is, and these keys that I've mentioned here, again, it is something that is understood by the rule engine that we define. Okay, it says fact is context. Context is basically, think of it as a place where all the state of your application or your component resides in. Okay, the operator right now, let's say this particular framework has this operator or many other operators to offers, but you can go ahead and add your own operator as well. It says the operator is not in, the value is this, and what we are telling to the rule engine is, okay, when you have the context available, when you have the entire state available, go to this path, go to campaign and dot value, use this operator, use this value, and if the operation comes out to be truthy, just blindly go ahead and spit out this failure message. Now spit out this failure message which we just saw, campaign and cannot be empty, spit out the failure message on the screen. Okay, if the condition comes out to be truthy. Okay. Now let's look at a more imperative example. And one more important thing here is, this can be present as a part of your components in the asset factory. Why? Because these things you already know beforehand. And the second example that we saw, that the drop down just vanishes when you choose the second radio button, is something that is dependent upon the user behavior and you might not know ahead of time. So sometimes the question is not who is doing the validation, but when is the validation is being performed. So I would call it more of an imperative, although it follows the same format, it follows the same configuration-based format, but let's see why it is called an imperative rule. So again, it's a logical and or a logical or of all the conditions, but in this case, it's a logical and. It says, go to the state, the entire state available, the operator is equal, and some value that you provide, check this path in the state, cost model dot value, okay. Do a logical and with this particular thing, total budget. Again, take the value from the state and then compare it. If the value comes out to be true, if it's successful, the display is true. Otherwise, the display is false. So now, why is it an imperative rule? Because this is something that you do not know ahead of time that this is going to happen. I'll come to this later, what the states or run validation, invoke, and all of these things actually mean. But this is something that you will have to fire, okay? So let's say the user clicks on that particular second radio button, you will have to fire it on your own, and then the rule engine is going to run that validation for you, okay? Now, the important thing to notice here is that we are not saying that everything has to go to a config, okay? There will be parts of the application where obviously coding will be required, but there are parts of the application such as these things where repetitive coding is not required. It's more about, and also it's more about correctness of the code rather than writing the code. Because see, if it's a more config based or a declarative approach, the chances of a developer going wrong are very less, okay? And this is a logical separation between the imperative code and declarative code, because these rules or these things that you would have otherwise written in an if-else condition will not change, right? These things are not going to change, so it's better to have a more declarative approach here. Now comes the most important part, which is putting all the workflows together. Now, what do workflows mean? Like I mentioned earlier, workflows can be defined as a series of steps where user is allowed to navigate between them. Like I mentioned earlier, in any advertisement format that we have, the user has to go through multiple steps to finally create the advertisement, okay? He can go back whenever he wants, but there are certain rules or guarded transitions that we just talked about. The rules have to pass so that the user can go ahead in the multi-step process, okay? Now, on a high level, if I have to tell you how does the process look like, is this is, let's say, the entry point. This is, let's say, the exit point, and you have the campaign details component where you fill in or punch in the campaign details. Then let's say you have a campaign scheduling and budgeting step where you would schedule your campaign, when is your ad campaign going to run, and the budgeting for it. Finally is the payment step where you make the payment, and when you're done, your advertisement is live. So if you look at it, right, it is actually a cyclic graph, okay? And it has, I mean, this is a simple example. Again, these are transitions that are made here, because like I mentioned, the user can come back, but the forward transitions have to be guarded, like I mentioned. So it is a cyclic graph, if you see. And I also feel that it's also important not to reinvent the wheel every time. So we chose to, use a library that fits this use case very well and aligns with it. So we've been using XState for this workflow management. The entire thing that we saw earlier, we call it a workflow. So we use XState for workflow management. Why? Because it also works on the concept of finite state machines. Okay, finite state machines also say that at any given point in time, you can be only in one state. So in this example also, right, you can be either in campaign details, or you could either be doing campaign scheduling or the payment. You cannot be in multiple states at the same time. XState also works along the same lines, and the good thing is XState has a concept of guarded transitions, and it basically, if I have to, put down this graph in the form of a code, XState serves the purpose. You can go from one state to another. You can define your machines. Okay, you can define your machines and the guarded transitions. Let's see how you define that in XState. So I'm not going to go into what is the syntax for this. You can go, the XState documentation is actually really good. This is how you define your states. So two things reside in the XState machine that is generated by XState. One is your entire state of the application, which you could call as a global state, and the transitions. This is basically the transition part. And the good thing is XState actually comes with a tool called Stately, where you can visualize what you have written. So you have to take this config, you have to punch it into their tool called Stately, and it will give you this. It will spit out this. Personally, I feel it is very important, because it's very useful, because it makes the job of the peer reviewer also very easy, because you can literally visualize what is going to happen when the code goes live. So This is the configuration if you give it to the tool called stately, right? We have been using it to create our transitions and the steps that I just showed you. So, I mean, it depicts the same thing, that you're on step 1, there is some guarded transition. There is a concept of guarded transition here. There is some guarded transition. If the condition passes, you go to step 2. Otherwise, what happens is, even if you go to step 2, you can, come back to the previous step. Or, let's say what happens if this is, let's say, a guarded transition, right? If the condition is falsy, then what happens is, there is a previous transition here. Now, so you come back to the previous state. And similar thing happens with the step 3, and similar thing happens with the submit step, okay? So when the condition is true, let's say you've submitted the ad campaign, and when the condition is true, you go to the submit step and your state is done. Now, when the state is done, the machine or the entire process comes into an ideal state. This is called an ideal state in X-state, where you are no longer in any intermediate state. You have reached the final state, and there cannot be any other state after this, okay? So I'd like to end the talk by saying that, okay, if you combine all of these things, right? So I think there is a good logical separation of what has to be kept declarative and what has to be coded. Okay. Thank you. That was my time. Thanks a lot.